I'm going to present the Chisel Implementation of NVDLA. My name is Yuda Wang, and my GitHub ID is Red Panda 3.
Just the green button.
Okay. Yeah.
Go ahead.
The first NVDLA is the NVIDIA Deep Learning Accelerator. It's a free and open architecture that promotes a standard way to design deep learning inference accelerators according to the primer. And I want to emphasize the standard, why standard is important. First reason is the accelerator is not only multiply and accumulate. I witnessed from the small Mac to big Mac to even larger Mac, it's always the Mac multiply and add. It's not so simple thing. It needs some interfaces and transactions. And thank you for McDonald's. The other thing is the concept of the hardware community. A good standard hardware can help us to build a decent community. For example, the ONNC, which is the Open Neural Network Compiler. The second one is the TVM, VTA, which is the versatile tensor accelerator, and they support the Chisel 3. Let's talk about why the agility is important. Because when I asked the NVDLA engineer how to make some modifications, they tell me Verilog. And yeah, he is correct, because the C mode is only the system C is only for the functionality, and V mode is for the multi-clock domain, and but it requires 300 to 600,000 lines of code. So you need a flow to optimize both for agility and performance. And sometimes only targeting the performance might including more manpower. But however, into this book called The Mythical Month said the Brooks Law, adding manpower to a late software project make it later. Because if you, the book said, if you want, it's not that simple that human power multiplied the months can result to a project. It's not that a simple multiplication relationship, because there's some cost for the communication. Another is why the RISC-V flow is not suitable for the accelerators. Accelerators, which in the book is the microcoded architecture. The control line is no, it doesn't pipeline the control, but it pipelines the data. And the IPC, which is the instruction versus cycles, which is smaller than one. And talking about single pipeline CPU, we pipeline the control, we pipeline the data, and the IPC is close to one. So that is the essence of the difference. And according to another, this is the early TPU article. In the performance is determined by the computational unit and the data transfer time. this is the roof line model. So in the left of the knee corner here, it is constrained by the computational power, and in the right is constrained by the data transfer. And so there are two major important parts. One is the computational unit. Another is the transfer time. For more computational unit, more Big Macs, vinaigrette, weight compression, and prune. And for the data transfer time, you need a good Bible, you need a good pipe, and you need a RAM. Let's talk about the autonomy of the soda, the origin. It is from the word just so in Chinese, because we like to say, how are you doing? And we say just so. It's neither too good or too bad. And it is from kind of depression culture. But actually, it's not just so. It's a fast flow for soda using chisel. There are two parts of the fast. I use. One is the bundle. As to how to exploit the bundle. Here is the OpenDLA interfaces. This is you can see this part in the NVDLA hardware and the spec. When you need you write some program into the CDMA and the CSB, and then you write into the buffer. The buffer read into the sequential controller, and the sequential controller map the K of the map reduce of the atomic C. And then the CMAC get the case of the CMAC result, and the result go, this is the convolutional result, and it go to the sigmoid or activation layer. This is the pooling data layer, and this is the cross-channel process engine. And this is the CSB. So CSB transfer the configuration files to the data to each of the discrete processors. So in the original NVDLA flow, they use some script to process the OpenDLA interfaces, and I exploit the bundle. Here's that. Some other transactions like CSB to DP and the W write DMA, every DMA, and the clock interfaces and the register control interfaces. And here is the ping pong schemes. Ping pong schemes is like in the first cycle. As in the first cycle, the DP works, and also the CSB read CSB has already loaded the second set of the instruction. So it's like ping and pong, and so it can save the time of the reading the instructions. So in the first instructions, here is the ping, and the second instruction, this is the pong. And in the field, it's always a bunch of the configurations. So I pack them into the parameters, into a bundle. You can find it under the submodule, some configuration Scala. And the second part is how I exploit the generators. First is the pro-related modules. They have already give you some script to generate these modules. Flop, read time, bubble collapse pipe, input skip type pipes. These two pipes are these two pipes are the certain pipes to fix the timing. So I make them into the generator. This one is from the Chisel, and this one is from the Chisel. And this is a famous question. What is the code generated by NAS? Because NAS is NAS is an in-house tool in the NVIDIA. So I just recreated the modules in the NAS. These are NVDLA 5 volts and the NVDLA ARP. These two important modules are from what I concluded in the files in the NVDLA hardware. So I make them into the generators. And this is the SOMNIA. SOMNIA is from the word of the insomnia. As to memorize the time I sacrificed in the library because I cannot sleep very well these years, and this is inspired by the scaling deep learning inference with multi-chip module-based architecture from SOPHIA, and this is a scale version of the from the NVDLA, and I make it into some educational core. And a common problem is how to avoid the license, because in the open source world, you have to avoid the commercial EDA. This is the control. The picture is very small, so I explain it. First, it depends on whether it's small or large. If it's small, then go to the equivalent checking, or you have to divide it into the small pieces. And after it goes to the uses equivalent checking, sometimes it doesn't work, so you have to pass it into the Pigpoke tester to test it manually, and then to get the result. Or other ways, you can use the VTA, which is the versatile tensor accelerator under the TVM, which is the latest update. Yeah, and another question is, when we talk about self-driving car, is AI and the CNN enough? A is no, B is no, C is no, D is no. Yeah, your answer is correct. The correct answer is C. Because in the self-driving car, what you can only do is the behavior cloning, means the car can follow the drivers and can clone the driver's behavior. Another is to detect the lanes and detect the vehicles, detect the pedestrians. With more and more people going to the AIoT, I think it's time for switching to CIoT. And the core extension is for CIoT. It can do, and this is some of the accelerator functions. One is the localizations. For example, the GPS is not enough because it has the high uncertainty and controls, including the PID control and the MPC control. And the trajectory generation means given a certain point, a certain waypoint, it can generate the trajectory. And the prediction means predict all the behavior of all the surroundings, and the behavior decision, which is you need the FSM, but a finite state element machine to predict, to make some decision. But this is a CPU, so it can do like some of the CPU did. And for the common filter, because LiDAR this is a car. You need some camera in front of the car, and you need a LiDAR and the radar inside. Because LiDAR and the radar is different, LiDAR can only detect, measure the accurate location, and the radar can both measure the location and the velocity. So you need a common filter engine to accelerate this function. And the control, including the PID control, the steer is equal. For example, this is the trajectory, and this is the car. So the car can move around the trajectory until it goes to the minimum CTE, crosstalk error. And this is for the trajectory generation. The car, after the car can, for example, you get some A or A star algorithm. You can decide the car, where should be the correct waypoint. After the correct waypoint, for example, this is another car, so the car should move around this. So how you generate the correct trajectory. This is a real time. So and more evenly, this is in the driveway. So this is another car. So you need to make decisions and make a best polynomial. Core is not open source; it's still under development, and soDLA and the core extension has been timestamped on this service, timestamp.decrypt.org, and it is a way to proof of existence. And if you are also interested in this project, or you want to sponsor this project, send an email to me or submit an issue. Finally, I want to thank for the contributors, Leisure Black, Blue Dog, and Cool Boy. And frequently, I often answer some questions on guitars. Thanks for Jack Koenig, Skylar. And I also want to thank for the PGA and the NVDLA fire sim test. They are Professor Zhao and his student Christina Zhang. They are They are in Chinese academic of science, computer engineer, and Xinbin Wang. He got a new son, so congratulations. And the developers of Chisel, Virtual, NVDLA, FireSim, VTA, and USIS wish Chisel Community Conference will be better and better. Do you have any questions?